Okay, so on Friday we talked about how to solve logs um, using the properties of logs. And we went over these 4 steps, used the laws of logarithms to condense first. Then we are able to drop the logs. That's their second step. Third step, solve. And there's different ways depending on what, sometimes it's a linear, sometimes it's a quadratic, sometimes it's exponential. Depends on the problem we're looking at. And then lastly, to check to make sure we're not taking the log of a negative, we went over some examples and you had some homework 1 through 10 which were like those examples. So now we're getting to the second part of the notes here. And these problems will look a little different. And if we look at these 4 steps that we're going to follow, are they any different than the the 4 steps in the first part? Or are they the same 4 steps? Take a quick look. There actually is a difference. Can you catch the difference? What step? Step 2. Step 2 here is to rewrite the equation in exponential form, where step 2 in the previous one was to get rid of the logs. And the difference, if you look at these problems here, one side doesn't have a log in it, the other side does. Okay, so that's why step 2 is looking a little different. So in these examples, we're solving for x. If we have pi or e, we're going to leave those answers in terms of pi or e. We're not going to approximate, meaning we're not going to use a calculator. And we're going to, some problems, they're just letting us know we'll have no solution. So that's why step 4 is important to check. Okay. So step 1, again, is to condense the log. And so on the left-hand side, we have 2 logs that we need to subtract. And as we've done in the past, we use the quotient property and write 28 over x equal to 2. Okay, so that's step 1. And then step 2, if you have logs on both sides, then step 2 would be to drop the logs. But here, if you have just one log and you want to get rid of a log, you got to change it from log form to exponential form. And that's not too hard to do. So 4 is our base. What's our exponent? 2. That's what a log is equal to. Log is equal to the exponent. And then you set that 4 squared equal to the 28 over x, the part you're taking the log of. And so now you have an equation without logs to solve for x. And we get 16. We do the 16 over 1 is 28 over x. Cross multiply. You get 16x is 28. And then we could divide by 16 and reduce. So what number goes into both 28 and 16? 4. Okay, so 4 goes into 28 how many times? 7, and 4 goes into 16 4 times. So 7/4 as much as we can reduce that down to. And then step 4, just take a quick check. If we plug 7/4 back in for x, will it be positive? Will we be taking the log of a positive number? Yes, we'll be taking the log of 7/4, and that's positive. So why don't you try the next one? Log x plus log 4 equals 3. First step is to add the logs. So you write log of 4x equals 3. And then what do you do next for that? Okay, the base is 10. If they don't write the base, it's 10. So it's 10 to the third power is equal to 4 times x. That's changing it out of log form, putting it into exponential form. 10 to the third power is 1,000. And then you divide 1,000 by 4. What's 1,000 divided by 4? 250. And if we plug 250 in for x here, we're still going to take the log of a positive number, so we get to keep that. Okay. Try the next one. Okay, so on this one, step 1 is to condense. Do we need to condense? No. So then step 2 is to change it out of log form into exponential form. And we know that because there's only one log on one side and not on the other. And what's our base here? If you have the ln, e is the hidden base. So there's only 2 hidden bases that we need to know about. If you have log, it's base 10. If you have ln, it's base e. So we get e to the negative 2 is equal to x. And so we've already solved for x. E to the negative 2. And so that could be your answer. Typically, we say don't leave the exponent negative, so we could write 1 over e squared is equal to x. Question on that? Any of those 3 so far? Okay. Try this next one. Log base 3 of x minus 5 plus log base 3 of 3 equals 4. Okay, so we add the 2 logs by multiplying the x minus 5 and the 3. So log 3, I'm going to put the 3 in front, so 3 times x minus 5 is equal to 4. Change it out of log form, so 3 to the 4th power is 3 times x minus 5. 3 to the 4th power is 81 is 3x minus 15. Add 15 to both sides. 81 plus 15 is 96. Divided by 3 on both sides. 96 divided by 3 is 32. And then check, if I plug 32 in for x here, I get 32 minus 5, which is still positive, and so that we get to keep 32. Going, try the next one. 3 natural log of 2 plus natural log of x is 5.
Proportion.
Okay, so on this one, we need to condense first. When you're condensing, first thing you look for is to use the power property, and we can do that here. So because we have a 3 in front of the natural log, so we get a natural log of 2 to the 3rd power plus the natural log of x is 5. And then we're going to add the 2 natural logs, and we get natural log of 2 to the 3rd, which is 8 times x. So natural log of 8x is equal to 5. If it's natural log, we're working with base e. So when we change it out of log form, we're going to take the base e to the power of 5. That's what your natural log is equal to 8x. And so if we're solving this, we divide both sides by 8. And so we get x is e to the 5th over 8. And e represents a number roughly 2.7. So 2.7 to the 5th power over 8 is still going to be a positive answer. And if we plug that in for x here, we're going to take the natural log of a positive number. So we get to keep that one. All right, on the next page, got 2 more. So here, log 2 times log base pi of 5 plus log base pi of x is equal to 3. Again, try it out. So you need to condense, not expand. So 2 is going to become the power of 5, and we get log base pi of 5 squared plus the log base pi of x is equal to 3. And then when we add the 2 logs, we multiply. So log base pi of 25x equals 3. So at this stage, we're not dropping the log. We can't do that because we don't have a log on both sides, so we have to change it out of log form into exponential form. So we take the base pi, raise it to the power of 3, and set that equal to 25x. Okay, so that's changing it from log form to exponential form, and then divide both sides by 25 to solve for x. And so our answer should be pi cubed over 25. And pi is a positive number, and so pi cubed over 25 is a positive number, and when we plug that in to this log, it's acceptable. Okay. The last one on our notes, log base 7, 3x minus log base 7 of x minus 2 equals 0. Give that one a try. Okay, so here, when we condense the log, we have log base 7 of 3x divided by x minus 2 is equal to 0. We change it out of log form. 7 to the power of 0 is 3x over x minus 2. And anything to the power of 0 is 1. Okay? And 1, you could change that to a fraction, 1 over 1, and cross multiply. You get 3x is equal to x minus 2. And then what do we do to solve? Subtract x from both sides. So 2 times x is negative 2, and then divide by 2. So x is negative 1. And then just check to make sure if I plug in that negative 1, I get log of negative 3, which is not acceptable. And I also get log of another negative 3, so not going to work. So no solution. Okay. Okay, so the homework